Thank you all for joining us today. I'm Amit Goel. I head up our product management for autonomous machines at NVIDIA. I've been working on the edge AI space even before maybe edge AI was on that hype cycle. So we started working on edge AI about 7 years ago. So we've had the opportunity to see up close the transformation of it, moving up the hype cycle, and then falling off it. So today what I'll be sharing with you is some of the success stories and areas where we're seeing the adoption of this technology, and also give you a glimpse into what's coming next. I think Zach mentioned a lot of things that we're doing together with Edge Impulse, so I'll give a little bit more insight into why those things are important. So first, let's get started by looking at the impact AI is making. We saw that in the chart that AI and edge AI is falling off the hype cycle, and there is a good reason for that. If you go around and looking at every industry, we see that AI is now being adopted and deployed in production. Huge industries, trillion-dollar industries, adopting AI at pace that was not seen before. In manufacturing, every manufacturing line that you see today would have a system that would be using AI to do quality inspection, keeping its workers safe, moving things around in the facility without having to spend people spending time walking miles and miles. In retail stores, you will see AI helping in checkout, helping in detecting of theft, keeping the stores clean, monitoring your shelves. And all of that is returning big value to the bottom line of the retailers and also improving the customer experience for people who are going into the stores. A lot of application in smart cities, keeping us safe, keeping our infrastructure running with best efficiency. We heard about healthcare, from things like wearable, but also what's happening in the theaters, in the hospitals, where robots are now assisting patients, providing better outcomes for them. Robots doing surgeries with minimum invasion so that you can recover faster from it. Another big area where AI is being adopted is logistics. Over the last few years, when COVID came, our e-commerce, logistics, warehouses were swamped with orders. And AI and automation played a huge role in making us get our products in time. So if you go to any warehouse today, there's a very high chance that you would see AI being deployed. It could be for picking things and sorting things, moving things around, looking at the parcels, whether the right product is being shipped at the right place. All of this is happening today with AI. Another area where huge adoption is happening is in agriculture. We had an event, I think last week, in Salinas, where over 24 companies were showing how farmers are able to use AI for improving their productivity, making agriculture more sustainable, using less herbicides for weeding, automating the tractors, making them safer to operate. So tremendous applications resulting in big benefits for these industries. AI is in our home. We all know the personal assistants that are running in our homes. But now there are more capabilities that are going to be coming soon with LLMs and more easy interaction that's going to be possible with AI. And last is metals and mining and heavy metal. This is an industry that is not very sexy, but has huge implications. The machines are expensive. The operations are expensive. Small improvements in efficiency can have huge benefits. So making the operations of these heavy equipment safer and more efficient is driving huge efficiency gains for these companies. Now, I'm pretty sure everybody who's sitting here doesn't need an explanation of why edge AI is needed. But I still, working in this industry, as I mentioned, for several years, I still see people struggle sometimes with the math. So I thought I'll share a few examples of what's happening and why edge AI is becoming important. And it's also, another thing to highlight here is that the expectations of what is, from what we want to do on the edge is changing every day, right? The first example is of a simple robot that has got 3 RGB cameras and a LiDAR, and it needs to use that to navigate. With the compression, the data that it generates is 2 gigabytes per minute. And there are many other robots that actually have double the sensor rate. So we see applications that can generate up to 4 to 10 gigabytes per minute of data. And there is no way you can send this data to a server for compute. Kate talked about things happening in the space. You have multispectral cameras. Just the intensity of that data is so high, and the expectations continue to grow. The second example is for latency. So I mentioned the agriculture and the farms. This is a John Deere tractor. It moves at 12 miles per hour. I don't know how many of you have had a chance to sit on one of these. If you look at that tractor and try to see the ground moving below you, it's impossible for a human to detect what's happening and act on it. This machine with 36 cameras is moving 12 miles per hour. At each instance, it's covering 2,100 square feet. 2,100 square foot at each instance. It needs to detect a weed. It needs to trigger an actuator to spray it. That's what is expected from the edge AI. And you can imagine to do this at the 12 miles per hour speed, the latency of your algorithm has to be really, really low. And the last one is cost. It's very easy to start POCs and projects, using the cloud, and which is awesome. But you have to question yourself: am I going to have 12 cameras or 24 cameras that are going to generate 1 hour of data? Or am I going to have one camera that's going to generate 24 hours of data, right? If you have 24 cameras generating an hour of data, it's great. You can send it to the cloud. And there is cost, because there's cost associated with it. It's the upload speed, it's the storage speed, the retrieval speed, and then the processing speed cost. But so it doesn't make sense probably to put AI in all those 24 devices. But if you have a single device that's generating 24 hours of data, which is the case for a lot of edge applications, right? Whether you're in the space, whether you're in a warehouse, whether you're a robot that's sorting parcels, you are creating data at high velocity for an extended period of time. And then the economics changes. You have to do it all on the edge. So all of these factors continue to drive more and more need for compute and performance on the edge. Another question that I often get asked, working in this space for so many years, is why can't I just use an accelerator, right? Why is accelerator not enough? There are so many options available. And the answer is accelerators are great and very useful, but not always. And to explain what is the difference between accelerated computing and accelerator, I was really thinking hard, how do I explain that without getting into too much of the details? So how many of you have been here to an amusement park? Okay, so hopefully everyone will understand what's going on here. So I want you to watch this animation closely, and I'll play it again later. So, quiz time. What was common between the two pipelines that you saw here? Both of them achieved the same objective. I'm sure you noticed one of them completed earlier, and the other one took longer. But there was something that was common between the two. Nobody wants to answer? OK. The time it took to take the ride between the two was the same. That is what is accelerated. If you go to a ride, You spend 4 minutes getting into it, putting the seatbelt, listening to the announcement. You get to enjoy the ride for a minute, and then you wait for another 3 minutes to get out. Right? That's what happens to your data if you're using an accelerator. You can accelerate the inference piece of it, which is the ride experience, but what happens before and after is not accelerated. But a lot of applications on the edge, as you saw for the tractor example, you need to accelerate every piece of the pipeline. You have to question everything from how the data gets in, how it gets to the accelerator, what do you do with the output. All of that needs to be accelerated. So there are applications where the whole pipeline needs to be accelerated. And that's why we at NVIDIA are purposefully building these processors which don't have just one IP in them. Our latest SoCs for the edge, which is Orin, has 8 different processors in it. And not just processors, but the high-speed IOs, the memory interfaces, all of that is optimized so that you're not at all limited by any piece of your pipeline. You can accelerate the full pipeline starting from the input to the output. And in the world of edge AI, the model itself is not is the product. That's not the product. That's the means to the end. So just accelerating the AI inference is not sufficient. You need to be able to build the entire product, your UI, your inputs, your outputs, everything needs to be accelerated. So we talked a lot about the benefits of AI, but putting AI on the edge is not easy. It has a lot of challenges. The first one is complex optimization. What do I mean by complex optimization? You have to think about not just about the accuracy of your model. You have to think about latency. You have to think about throughput. You have to think about concurrency. You have to think about quantization. And these are all interdependent variables. You change one, the other gets impacted as well. So depending on your application, you're looking at 8 or 9 different variables that you need to juggle to come up with an optimized solution. The second challenge with edge AI is data sets. Unlike AI applications for the internet where you have big data, plenty of data to train the models, a lot of the AI applications for the edge do not have that luxury. Finding that data, finding that needle in the haystack is hard. So that's what makes it really complex to deploy AI at the edge. And another area that we often come across is the go-to-market. Some of these industries, the way they've gone to market is by selling that equipment, selling the device to the end customer. But when you are talking about AI and intelligence, you are constantly improving that product. The promise of AI is that you're taking the data, you're learning from it, and making it better. So if you were just investing in a one-time sale, we often see people make wrong trade-offs. So there is a need for edge AI to also come with a business model innovation for these products. Synthetic data is one way we are trying to solve the data problem for edge AI. You can see 3 examples here, very different industries and seeing tremendous results by just using synthetic data. Coincidentally, I saw in Zach's chart that synthetic data was another thing that went off the hype cycle. So soft robotics using Omniverse to create synthetic data for identifying chicken pieces that its grippers have to pick. Festo is using synthetic data to detect the pose of this particular part that the robot needs to pick. And the last example is with Amazon Robotics, which is using it to detect packages for the robots that need to be picked. The second problem with the data problem that you have with data is that we are trying to solve is with tau. What we've done is we've taken a lot of these models and pre-trained them with large amounts of data. As it turns out, there's a lot of knowledge that gets encapsulated into these models that does not have to change from application to application. There are some aspects of it that need to be changed, but not the whole model. So we take a lot of different types of models, state-of-the-art models, pre-train them, and make the recipes available through Tau, so you can just bring a small subset of your data set, retrain it, and deploy it. And with Edge Impulse together now, we are able to not just target GPUs, but we can target GPUs, CPUs, microcontrollers, and all other accelerators. So with this, we are seeing that the data problem is also getting mitigated. And the two things put together, synthetic data and transfer learning, you really can be sitting in your home and creating an AI factory, right? This is a real-world example. Our team started working on segmenting people from the point of view of a robot. So we said, OK, where are we going to start? We already had a pre-trained model that could segment out people. But guess what? It was not trained from the perspective of a robot, which is looking at things 6 inches above the ground. So initially, the results were really bad. So we said, all right. We went into Omniverse. We spun off a bunch of people into that environment, put in a sensor, generated 200 images, feed that back into Tau, transfer learn a model, and within hours, we had a segmentation model that could detect and segment out people's leg from the point of view of a robot. So this is the scale at which AI is being generated. You could be sitting on a computer, and you could be running your AI factory for creating models. And all of this is possible now for enterprises with our work that we're doing with Edge Impulse. You can collect data with Omniverse, you can train the model with Tau, and you can deploy it on the edge with the Jetson, all from the same platform. So really exciting stuff. Now, I think a talk in today's time without generative AI and LLM would be incomplete. So I want to talk a little bit about how generative AI and large language models are making an impact on the edge. The first thing I want to talk about is this concept of knowledge distillation. The beauty of these large models and generative models and foundation models is that they've encapsulated a lot of the world information. So you do not need data anymore to say, right? When I said you don't need the data, I really mean the foundation data that a model needs to learn the features of the world, of the things that exist in the world, are already encoded into these models. But these models are, again, to serve a lot of things in the world. But when you are trying to solve a problem on the edge, you don't need that level of knowledge. So wouldn't it be great if I could just go to that model and extract out its piece of knowledge that it has learned for my particular use case? I only care about detecting a mouse. I'm tracking a mouse. I want to know how to segment a mouse. So it's possible now to take this giant model and extract out what we call knowledge distillation, a smaller model, take its learning, encode it into a smaller model. In this example, a simple ResNet-based convolutional neural network was trained from the mobile SAM, which is trained on a huge data set. And the result, as you can see here, a big data model like mobile SAM, which runs 146 milliseconds of latency, you can distill it down, extract it to your use case, and now you can run instance segmentation at 27 milliseconds on a Jetson ORN, right? 5x improvement in runtime and a lot smaller memory footprint. So even though it may not be possible to deploy these foundation models directly onto the edge, but the knowledge that is encoded into these models can really accelerate how you will be developing your models for the edge. The second area is where, thanks to the compute and the velocity at which the AI compute is coming to the edge, it's also possible to run these giant models themselves onto the devices. And we are starting to see some early signs of success in several areas, and I'll cover 3 of them today here. The first one is what we call embodied AI. Programming robots has been really hard. And it's hard to program them for a single task, but if the objective is to train them to do multiple things, the complexity gets even harder. So we are seeing this, that the combination of vision and language together as an input is being very powerful in creating actions. And you can think about the robot's job is really hard. It's every time it has to do something in the general world, the world looks different. And it's impossible for you to provide training data for all of that, right? So generative AI is super essential here because you can give it an example of 2 things, and it can extend it to 100 other things. With large language models, we are starting to see a lot of interactive kiosks. The experience for a person trying to navigate a mall or ordering the food is not the best today. And with this ability to have the natural conversation with the person, we will see that a lot of these kiosks will provide a lot better intelligence and really improve our experiences when we go to these places. And the third application that I'm super excited about is personal assistance. And when I'm talking about personal assistance, it's not the Alexas and the Googles, but a personal assistant for a disabled person. Today, if you were to give a person who cannot see the power of AI, it's extremely complex to build a product for them. A simple thing like, is it safe to cross a road, can be extremely hard to decide. You need to detect the things, you need to detect the depth, you need to track those things, then you need to have rules to say when is it safe to travel. And then how is that person going to interact with that AI? With the AI models today, like the one that I show here, you can actually just give it a scene and ask a question. What's going on here? Is it safe to go, right? You don't need to be a data scientist. You can talk to your AI. It can understand the word and give you a response in a way that you can understand. And the beauty is all of this is now possible to do on the edge. So I'm going to leave with this, that we have created a lot of tools and workflows. It's very early days, but we want to give the power of this to the developers. And with our playground for Edge AI on Jetson, you can get started today with all of the things that I mentioned. And I look forward to see what everyone develops. And I'm pretty excited about the future and how generative AI is going to really enable more applications for AI at the edge. So thank you.